Myself, Aishwarya Vitapnur, BSc second year, PCM combination, SSGFGC Nargun. My assignment topic name Structure of amines, basicity of aliphatic amines, aryl amines, and effect of substitution on basicity of aliphatic and aromatic amine, basicity of amines and amides. Introduction of amines, basicity of aliphatic amines, effect of substitution on basicity, basicity of amines versus amides. Amines, structure and classification. Amines are classified as a primary, secondary, or tertiary depending on the number of carbon groups bounded to nitrogen. Methylamine, dimethylamine, trimethylamine. Introduction to amine. Definition of amines. Amines are organic compounds derived from ammonia, where one or more hydrogen atoms are replaced by alkyl or aryl groups. General formula: primary amine, secondary amine, tertiary amine. Classification: primary, secondary, tertiary. Primary amines: one alkyl or aryl group. Secondary amine: two alkyl or aryl group. Tertiary amine: three alkyl or aryl groups. Order: weaker than ammonia and aliphatic amines. Resonance: the lone pair is delocalized into the benzene ring, making the nitrogen less available to accept a proton. Substituent effects: electron donating groups. Example: dimethyl ether. Electron withdrawing group. Example: nitrocyanohalogen group. Decrease in basicity. Structure: aniline is a weaker base than basicity of aliphatic amines. Order: generally secondary, primary, tertiary. In aqueous solution, through this can vary due to solvent effects and steric hindrance factors. Alkyl groups increase electron density on nitrogen, increases basicity. pKa: aliphatic amines generally have a higher pKa values than ammonia, indicating basicity order of aliphatic amine. Gas phase order follows the positive charge stability. Order follows the positive charge stability in aqueous solution. Effect of substituents: electron donating groups. Groups like NH2CH3OCH3 release electrons into the ring, increasing the electron density on the nitrogen's lone pair, making it more available for protonation. These increase the base strength. This is discussed further in this scribble document. Electron donating groups like NH2CH3OCH release electron into the ring, increase the electron density on the nitrogen lone pair, making it more available for protonation. These increase the base strength. This is discussed further in this scribble document. Electron withdrawing groups like nitrocyanohalogen group NH2CH3OCH3 release electrons into the ring, increasing the electron density on the nitrogen's lone pair, making it more available for protonation. These increase the base strength. This is discussed further in this scribbled document. Electron withdrawing groups like NO2CN CHO COOH full electrons away from the ring and the nitrogen atom. reducing the availability of the lone pair and decreasing basicity. Position effect, ortho meta para. Ortho para. These positions are highly influenced by resonance effects, making the impact of a EDZ or EWG stronger. Meta. Only the inductive effect operators. Ortho effect. Even electron donating groups, if placed in the ortho position, can reduce basicity due to steric hindrance, steric inhibition of protonation. Halogens example chloride. Chloride or bromide act as a weak electron withdrawing groups due to their high electronegativity, reducing the basicity of a aniline even though they are orthopara, directing in electrophile substitution. This is discussed further in the differences in basicity. Amine basicity. The nitrogen atom less a lone pair, almost neutral, available for a donation Lewis base. Aliphatic amines are generally stronger bases than ammonia due to the electron releasing inductive effect of alkyl groups. Amine basicity. The nitrogen atom has a lone pair, almost neutral, available for a donating Lewis base. Aliphatic amines are generally stronger bases than ammonia due to electron releasing inductive effect of alkyl groups. Amine basicity. Amides are a very weak bases, almost neutral, because the carbonyl groups is electron withdrawing group. Resonance stabilization involves the nitrogen lone pair decreasing electron density on nitrogen comparison. The conjugate acid of an amine has a pK of approximately 9.5, while that of an amide is around minus 0.5, highly gliding, a dramatic difference in basic strength. Effect of substitution on factors. Electron donating groups plus 1 effects. Alkyl groups example propane. Donate CH3CE2H5. Donate electron density towards the nitrogen. This increases the availability of the lone pair to accept a proton. Enchasing the amines basic characters. Electron withdrawing groups minus 1 effect. Groups like chlorine, bromine, or OH withdraw electrons, reducing the availability of the nitrogen's lone pair and decreasing basicity. Steric hindrance. While alkyl groups increase electron density, bulky groups on tertiary amines can hinder the ability of a solvent like water to stabilize. The amine cation, which can reduce its basicity in aqueous solution compared to secondary amine. Solvation effect in water. Primary and secondary amines are better solvated, stabilized by hydrogen bonding with water than bulky tertiary amines, affecting the aqueous base strength ordering. Resonance effects in amides. The nitrogen lone pair is involved in a resonance structure. This makes the nitrogen less likely to bond with a protonation site. Because of a resonance, if an amide is forced to protonate, it typically occurs on the oxygen atom rather than the nitrogen. Resonance effect in amides. The nitrogen lone pair is involved in a resonance structure. This makes amides almost neutral because the carbonyl groups is electron withdrawing, and resonance stabilization involves the nitrogen lone pair, decreases electron density on nitrogen comparison. The conjugate acid of an amine has a pK of approximately 9.5, while that of an amide is around minus 0.5, highly gliding. Amides are weakly basic because of the delocalization of the lone pair of electrons or nitrogen over the system OCN. Thus, it is relatively unavailable for accepting a proton. Hence, amides are weak bases, whereas in the case of amines, the lone pair of electrons is more easily available. In generally, amides are much less basic than amines. resonance structure, as amides are weakly basic. They form a salts with strong minerals acids. Means reference.